guys, so today we'll be talking about tangents and common tangents. So first, let's have an application problem. It's a segment PA and segment PB are tangent segments from point P. PO is equal to 17, OA is equal to 8, and measure of angle APO is 28. Find measure of angle POA and PB. So let's bring in a diagram. Here it shows the scenario, and I've marked in what the given is. So segment PO is equal to 8. That means that segment OA is also equal to 8. OB is also equal to 8 because they're both radii, and radii of a circle are always congruent. And then segment PO is equal to 17. And then segment APO is equal to 28 degrees. So in order to solve this, we're going to have to use the Pythagorean theorem. So we can write what's given. We can use the Pythagorean theorem to solve for the segment PB. So a squared plus b squared is equal to c squared. That's the Pythagorean theorem, and let's substitute what we know. So a squared is 8 squared, because that's segment AO, segment OA, plus b squared, which is what we're trying to find. So segment PB, tangent PB actually, which is equal to 17 squared, because that's PO. 17 squared. 8 squared is equal to 64 plus b squared, and then 17 squared is equal to 289. And then we subtract the 64 to get the b squared by itself, and then that is equal to 225. And then we're going to have to take the square root of that. So then b is equal to the square root of 225. And that means that b is equal to 15. Okay, just like that. So b here would be the PB, and we can write that in because that's what we know. So that's 15. And now we can figure out what the measure of angle POA is equal to. So if we look at measure of angle POA, that's this angle right here, and in order to find that, what we can do is take 180 degrees, and subtract that from this 28 degrees plus 90 degrees. So we know that angle PAO here is 90 degrees because whenever there's a tangent that bisects a circle, it always forms a 90-degree angle. So this is the tangent, and when it intersects this circle and there's a radius coming into it, that gives a 90-degree angle. So we can subtract 180 degrees from 90 plus 28, like that. And then that gives us measure of angle POA equal to 62 degrees. Like that. So that's how we solve this application problem. And next, we can talk about common tangents. So we have two examples here. Let's just go step by step. So the first kind of common tangent is the common internal tangent. So we have two circles here, circle A and circle B, and the dotted line represents how they're represents the segment that joins the centers. And common segments would be going in right past that and right past here. And it would be an internal tangent because these tangents are internal between the two circles. And then we also have tangent circles, which are internal tangent circles. And here we have circle A again, the large circle, and then circle B, the smaller circle within circle A. And the tangent of these two tangent circles would be this line right here. And its tangent in this point, and that's what we'd call the point of tangency. Same thing also with these two tangents. the point of tangencies would be right here and here and here and here. That's where the lines are tangent to the circles. And next, we can talk about common external tangents. So in this case, we have circle A and circle B with the dotted line representing the segment that joins the centers of the two circles. So the common external tangents would be this top line and this bottom line. They're the common external tangents because the circles are externally tangent to each other. And then here we have tangent circles. There's two of them, circle A and circle B again, and the external tangent would be going right in between both of them because it's on the external side of both of the circles. And these two circles are tangent circles because they're tangent to each other, and the point of tangency would be right there in the middle. So thanks for watching, guys.